Hello, ladies and gentlemen. This is me, Mr. Paramo, coming at you. Believe it or not, when I check my watch, it says it's 11:15, November 15th to 2 p.m. So on Friday, while you all are busy during sixth period, I am recording a lesson so that you can know how to do this Polar Lab while I will be in Clovis Veterans Memorial Building learning about Common Core Math 1. I'm just as excited as you are. So this is a little bit different than what you're used to. This is my face recorded to you using the camera on my laptop and a document camera where you could see what I'm going to be doing and showing you how to do today. So the video, sometimes my, video processor's a little bit slow, so sometimes my voice and my mouth are moving at different rates. But that's not going to stop me from teaching you today. So today, what we're going to be working on is the Polar Lab. So you're going to actually have to have your graphing calculator today to be able to do the Polar Lab. If you're wondering where the Polar Lab is, it is these 3 pages. Let me show you. You turn this over. Here's Polar Lab page number 1. Turn it over. Polar Lab page number 2. Turn it over. Polar Lab page number 3. This video that I'm showing you right now is the video for pages 1 and 2. So let me give you some guidelines so that you can be successful on this lab. I'm going to give you a hint to how to do these things. So for example, let me zoom in here on one of these things. Let's look at number 7 right there. I chose number 7 because that's what I zoomed in on. I'm going to actually graph this on my graphing calculator. So get out your graphing calculators if you have not done so already. If Miss Hopper is my sub, who I think it's going to be, please, if you need to press pause, go ahead and press pause right now so students can get out their calculators. If everybody's ready, let her know that you're ready. Because here I go. I'm going to graph r equals 3 cosine of 2 theta. And I'm going to need to put that graph here on this polar piece of paper. So I'm going to put my Texas Instruments TI-84 there. The first thing I need to check is my mode. So I'm going to go and press mode first, and this is the menu I get. When I look at this mode, the first thing that I see is that I'm in degrees. And what should I be in for any trig equation? I should be in radians. So I'm going to go down here and press radians and press enter. Same thing on the TI-89, same thing on the Casios. Right now, my calculator is set for functions. And we also learned already how to do parametric. Well, today we get to go into polar. So we're going to scroll over down here and put our calculators in polar mode. Once I have that, instead of when I press y equals, it's no longer going to be a y equals. It's now going to automatically know. Polar form is not y equals. Look at what happens when I press. Look what variable's over here. That lets me know I'm in polar form. The calculator already knows. If you have a Casio by chance, the Casios, if it says y equals here, then that particular equation is still in function mode. You might have to delete it when you switch between one mode and the other. There's a way to do that. Just look at the menus that are on the bottom of your calculator. Hopefully that will help any of you. So here's what I'm going to do. I'm going to put in this equation here, 3 cosine of 2 theta, into this calculator. I'm going to press 3 cosine of 2 theta. And I'm going to press enter. The lights just went out. Hang on. Had to shed some light on the subject, if you will. So we have this. Here's our equation. I made a recommendation at the top of your things. Let's use the default zoom window number 7 trig. I'll show you what I mean. What that means is instead of setting our window by hand, what we're going to do is we're going to press the zoom key. And I want to use number 7, the zoom trig. That will be pretty much what we need for today. Bam! There you go. That's our graph. That was pretty exciting. Let me do that again. 2 theta enter graph. Pretty cool, right? So now I'm going to take this picture and put it into my graph. You might not know how far this is, and we're going to need to know how far this, let's call this a rose petal. Ladies, there you go. There you go. You got some roses today. Gentlemen, you got some roses today too. So we're going to figure out how big this rose petal is. I need to know how far out this is. So one of the buttons I'm going to use is the trace button, which is right there. Let me press trace. What this is telling me is that I am at 3, 0 when theta is 0. When my angle is 0 radians, I'm at the position of 3, 0. So when I go over here to this, and I'm going to have to draw this in my graph, I'm going to go over how many rings? I'm going to go over 3 rings. If I want, I can go and do this. Every single ring is 1, 2, 3. I can do that. Or if I think that's too small, I can even go by 2s. 1, 2, 3. And I'm going to just label it. This is 3, 0 right there. That's my point. This is the radius. This is how far that petal is right there. Now, if I press the right arrow, I can see where my cursor is when the angle changes. As the angle gets bigger, then I can see that this thing is getting smaller, but I can find my position where I'm at, and so on and so forth. So if I want to see where I'm at right here, I can see that y is -3 when x is 6.13 times 10 to the -10th. This means times 10 to the -10th. So which basically is 0.00000010 zeros and then 6153. So you can see how far each petal is in the direction. So here's what I'm going to do. I'm going to do my best attempt at drawing. Well, if that's 3, then I need to be 3, and then I need to be 3, and then I need to be 1, 2, 3 right there. So I need to do my best attempt at drawing this graph. And sometimes what I like to do, and I just realized it right now, I like to draw it in the same way that the graphing calculator graphs it. So let me look at where it starts, because that's kind of important here. Let me go back here. Let me press 2 theta again, because then it's not going to know that it already graphed it. And I'm going to press graph, but watch where it starts and watch the direction that it goes. It started here, then it went here, then it went here, then it went here, then it went down, then it went up, then it went down and around this way, then it went this way, then it went this way. And I'm going to follow the same way when I graph it. So actually I should start here, and then I go up and around, then I go down here, then I go this way, then I go that way, then I go here, then I go there, and I go up there, and I finish right there. That's as close as I possibly can do at this point. So what I want you to do is I want you to do these first 2 pages of these equations. I want you to be able to answer the questions that are above and below, and then look for things that might tell you how to do this without a calculator. My goal is you should be able to do this right now with a calculator, and then make some observations as you go along that you would be able to do this without a graphing calculator. Okay? So, have fun with that. If you notice how I graphed this, how I went around that way, that's going to be there's going to be a big reason why I do it that way, and I'm going to be doing that on the back of the worksheet when we get to the worksheet 3 of this lab. So, right now I want you to do the rest of this whole thing. Make sure you're answering these questions. If you're not sure how to do it, get with a partner, work together. You all may work together. Don't be afraid to talk to each other. This is a lab. It's an experiment. Think of it like that. You're going to be learning about certain shapes. The shapes you're going to be learning about are the petal graphs. Sometimes they're called rose graphs. You are going to be learning about things called cardioids. And you're going to be learning about things called limaçons. That's a French word, and you know how I like French fries. Answer those questions. If you want to, you can actually go to the next worksheet and see if you can answer it, but I am going to do a separate video for this. So feel free to try it when you get there, but I'm going to wait for the majority of the class to be ready, and then I'm going to do another video for the backside. So get started and let the substitute know when you are ready for the second video.